A1, here's the problem you were working on. So we have the integral of x to the third times the square root of x squared plus 1 dx. So first let's rewrite it using rational exponent instead of a radical. So it's x to the third times x squared plus 1 to the 1/2 dx. Now you were right, you had the right substitution, you just didn't take it far enough. So you have u equals x squared plus 1, so du is 2x dx, and you just divide both sides by 2, don't divide by 2x, so you get 1/2 du equals x dx. Now we want to try to get rid of all of the x's in our integrand, and if we rewrite the integrand a little bit, you'll see how we can do that. So I'm just going to rearrange it. I'm writing x squared plus 1 to the 1/2 first, and then I'm splitting up the x to the third. X to the third is x squared times x. So we see we have, we can get rid of the x squared plus 1, we can get rid of the x times dx, but what are we going to do with the x squared? Well, go back up to the substitution that we're making. If u is equal to x squared plus 1, that means that x squared is just u minus 1. So now we can get rid of all of the x's. So let's go back to the integral, and x squared plus 1 to the 1/2 is going to be u to the 1/2. X squared is going to be u minus 1, and x dx will be 1/2 du. And so now you can get rid of everything. All the x's will go away. So you have u to the 1/2 times u minus 1 times 1/2 du. So you can bring that 1/2 out in front and distribute the u to the 1/2. U to the 1/2 times u is u to the 3/2, and u to the 1/2 times 1 is u to the 1/2. And so now you can integrate that. So increase the exponent by 1 and divide by that number. Increase the exponent by 1 and divide by that number. And now don't forget that you have to go all the way back to x's. So we have to put x squared plus 1 in where we had all of those u's. So here's the answer. Okay, let me know if you have any more questions.